Caching is the process of storing some data in cache. Cache is a temporary storage component area where the data is stored so that in future, data can be served faster. Think of it as a little package box that we store information in so that we don't have to travel all the way back to wherever we're going to retrieve this information. We have a package that is a lot closer to us that can give us this information a lot sooner. Now, in order for us to really understand caching, we have to go to the very basic steps. That is talking about CPUs, random access memory or RAM, and hard disks. Now, CPUs are built with a special on-chip memory called registers, which usually consists of a small amount of fast storage. So CPUs nowadays actually have a bit of memory as well, besides just doing all the work or being the brain of our computers. They're the closest and smallest memory storage in our computers, but also the fastest. Sometimes you may have heard of these registers as L0 cache, L1 cache, L3, L4 cache. And all these caches depend, whether they exist or not, on the architecture of the chip. But they're used as a super fast way to access memory, the fastest we can go. And then we have something like RAM, or random access memory. They're again closer to the CPU, not as close as the registers were, the small little pieces of memory that the CPU had, but large enough that can hold significant information that the CPU can access information from and use it. Again, because this is in memory, as soon as the power goes off of our computers, well, that information is gone. But because it is in memory, well, it's also fast to access. And then we have something like hard disk drives. And these were physical disks that we had in our computer. Now, these are, in newer computers, you'll find something like solid state drives that actually make accessing information a lot faster. But the difference between RAM and this hard disk drive is the performance, cost, and the proximity to the CPU. You see, as we go down the line, it becomes cheaper and cheaper. But also, it becomes slower and slower to access this memory. For the CPU to access disk memory, well, it has to travel a longer distance, and the disk takes a longer time to give that information to the CPU. But the added benefit is that even if the power goes off, this disk will remember our information. Again, versus the RAM that stores only temporary data, the disk is able to store long-term data. Okay, but why do we just learn about this? How is this useful to us? You see, because caching is actually everywhere. And most people might not realize how many places we can actually cache things. Similar ways in which we're able to access memory or access data a lot faster in our computers using CPU, RAM, and hard disks. Well, we can do the same similar principles in our applications. For example, we use CDNs to cache our HTML, CSS, and JavaScript files so that instead of the browser going all the way back to the server across the country, across the globe, it can just access the closest server, CDN, and use the cached files. There's also things that we can cache on the server. For example, on the server, if I was accessing some sort of an API that returns me robots, well, so that I don't have to request that every time, maybe I can cache that robot information, perhaps in a variable, perhaps in a memory storage like Redis, or perhaps even in a database if the API is really slow. We can also use caching on the database side. And database servers will be configured out of the box usually for optimal caching, but they do also allow you to control and change parameters based on your needs. And then we also talked about Redis. And we know all about Redis now. We use it to manage our session tokens. When I taught you about Redis, you thought, all right, Andre, he's teaching me about another useless database. This is a waste of time. But then you slowly started to come around and I showed you that you can manage sessions using Redis and it's really fast. What if I told you that we can use Redis for caching database requests as well? Something that we've talked about a little bit in the database scaling video. For example, if we had a node server and we had to make a request to the database, well, I can first place my Redis server right in between us. And I can ask the Redis server, hey, do you have this user information? If it doesn't, well, we go to the database, retrieve that information through SQL, and send it back to the node server. But before we just send it directly back, we go through Redis, store that information in memory, and then pass it back to the server. So that the next time the server asks for the same information, we go through Redis. Redis says, oh yeah, I have it, here you go. And we avoid the SQL statement and the disk access that most likely would happen with a database. And that's something that you really want to do. Before you do any sort of database scaling where we start working with the database, you want to figure out, hey, can I cache? Can I use Redis or Memcached to cache our requests or our queries? And there's so many other places that you can cache things. For example, the most common one and the one that you're probably most familiar with is caching on the client side or on the browser. You see, the browsers give us a ton of ways to cache information. And we're going to dive a little bit deeper into this topic because you can do some really exciting performance optimizations with it. So for that one, you'll have to wait until the next video. See you then. Bye-bye.